In this video, I'll show you how to solve the ALEKS problem called predicting bond angles in a small organic molecule. This problem is going to give us a Lewis structure and ask us to predict two of the bond angles in the structure. So the first angle that it's asking us to predict is angle A, and angle A is the hydrogen-oxygen-carbon bond angle. To predict a bond angle, we have to count the number of areas of electrons around the central atom of the particular angle. So if we're focusing on angle A, which is hydrogen-oxygen-carbon, our central atom in that set is the oxygen atom, and we want to know how many areas of electrons are around the oxygen. Oxygen has one bond, which counts as one area. It has a second bond, which counts as a second area, and then it has two lone pairs. Each of those count as their own area. If you have 4 areas of electrons around a central atom, that's a tetrahedral arrangement, and that bond angle is 109.5. Now, based on like where you're at in chemistry, you might say, oh, but I've got lone pairs. That's going to cause a little deviation to this bond angle. Well, notice that the ALEKS problem is saying give the ideal angles. Don't worry about differences in that angle. So it just wants us to answer 109.5 for that angle. Now, the other angle that we're being asked to predict is B, angle B, and that is the oxygen-carbon-nitrogen bond angle. So again, we're going to focus on our central atom in that set. That's a carbon. And around the carbon atom, we have 2 areas of electrons, 2 bonds, 2 areas of electrons. When you have 2 areas of electrons, that bond angle is 180 degrees. And just to add on this, in case you have a variation in your particular problems, if you have 3 areas, that's going to be 120 degrees.